All right, welcome to The Explainer. Today, we're diving into something really cool, a totally new way to think about artificial intelligence. It's an idea that pulls from physics, from psychology, and, believe it or not, from the very nature of a good story. So let's just jump right in with a question. It seems simple, but the answer is surprisingly deep. How does a story actually work? How do you understand it? When you think about it, there are really two ways to digest a story. On one hand, you can see the whole thing at once. You grasp the entire arc, the full journey from the first page to the last. On the other hand, you can live it moment by moment, the play-by-play, following the action as it unfolds. In this split perspective, it's not just for stories. That same idea, it turns out, is a perfect mirror for a powerful concept from classical physics, which, you guessed it, also has two completely different ways of describing how the universe works. Okay, so the first way is called the Lagrangian view. Now stick with me here. Imagine you throw a ball. Lagrangian mechanics doesn't just track the forces on it second by second. Nope, it's much bigger picture. It looks at every possible path that ball could have taken, and it finds the one single path that was the most efficient, the one that minimizes something called action. You can basically think of action as the total cost of the trip, in terms of energy and time. It's like it's finding the most elegant plot for the ball's entire journey. And then you've got the complete opposite, the Hamiltonian view. This one is all about the now. It looks at the system's state right at this very instant, where it is, how fast it's going, and uses its current energy, the Hamiltonian, to predict what's going to happen in the very next moment. It's the ultimate play-by-play, a step-by-step reality show. Now, here's where it gets really mind-bending. This whole duality from physics, the big picture story versus the moment-to-moment action, it's a perfect parallel for how our own brains handle time. And this connection was brought to light by the amazing psychologist and Nobel laureate Daniel Kahneman. So Kahneman figured out that we basically have two selves running the show. First, there's the experiencing self. This is the part of you that lives completely in the present. Feeling the cold water when you jump in a pool, or the pure boredom of a meeting that just won't end. Then you have the remembering self. And this self, it's a storyteller. It waits until everything's over and then constructs the story of what happened, deciding if it was a good or bad experience on the whole. And this is where it all clicks together. The experiencing self, that's pure Hamiltonian mechanics. It's the play-by-play of now, just processing life one instant at a time. But the remembering self, that's totally Lagrangian. It couldn't care less about every single second. It zooms out, looks at the whole trip, and judges the entire story arc. And this explains that wild quirk of our brains called the peak end roll. Think about it. We judge a vacation not by how long it was, but by its absolute best moment, the peak, and how it ended. A totally amazing 3-day weekend can easily feel better in our memory than a pretty good but kind of flat 2-week trip. Why? Because our inner storyteller, the remembering self, prioritizes the dramatic highlights over the total runtime. Okay, so physics, psychology. How on earth does this connect to AI? Well, it leads to this really game-changing question. What if we could teach an AI to think like our remembering self? What if it could learn not just a list of facts, but the actual plot of how things happen? And believe it or not, that is exactly what researchers are working on right now. They're trying to push AI beyond just seeing static snapshots of the world and get it to understand the dynamic shapes of processes, how things flow and change over time. The secret sauce here is something called a curve prototype. Just think of it like a reusable story arc that an AI learns from looking at tons of data. For instance, an AI could analyze medical data and learn the classic shape of a human stress response. That sharp spike up, a little plateau, and then a slow curve back down. That curve itself becomes a piece of knowledge, a fundamental pattern, a recognizable story. And they're actually building this with new kinds of AI models that are inspired directly by these physics concepts. You have things like Hamiltonian neural networks, which get really good at the play-by-play by learning a system's energy. And then you have others, like deep Lagrangian networks, which are designed to learn the entire story arc. The cool thing is, both of these approaches make the AI much better at predicting the future because they understand the why of a process, not just the what. And this brings us to a really crucial point. This isn't just some clever little engineering hack. This represents a massive shift in what we even mean by knowledge when we're talking about AI. See, the old way of giving AI knowledge was to build a static knowledge graph. It's basically a giant web of facts. You create a link between Socrates and human. Okay, it's true, but it's a dead fact. It's lifeless. It doesn't capture any kind of process or growth or story, but this new way, it sees knowledge as a living, breathing process. The AI can watch something start to happen, let's say a conversation that's getting a little tense. It can actually match the rising pattern of that tension to that stress response curve it already knows. And because it knows the typical shape of that story, it can actually anticipate how the rest of the conversation is probably going to play out. The benefits of thinking this way are just huge because the AI is learning the underlying story structure. It needs way less data. It gets much, much better at applying what it knows to totally new situations. And here's a big one. It becomes more interpretable. We can understand why it's making a prediction by just asking, hey, what story do you think is happening right now? And this is where we get to the really deep part of this idea. This isn't just a technical upgrade. It's a huge philosophical leap. We're moving toward an AI that understands reality not as a bunch of static objects, but as a constant, dynamic flow, a state of always becoming. I mean, listen to how the researchers pioneering this work describe it. They say that using the language of physics, this language of energy, of action, of trajectories, gives AI a fundamentally deeper toolkit for modeling our world. So that's the big idea right there. We are shifting from an AI that just knows what is, a simple static fact, to an AI that understands how things become, a living, unfolding process. It's moving from a world of things to a world of stories. And that just leaves us with one final, pretty mind-blowing thought. What happens next? What new possibilities open up for us when our technology can finally grasp not just the disconnected facts of our world, but the fundamental stories, the curves of becoming that truly shape it?